All right, well, welcome to Introduction to AI, uh, Machine Learning, Large Language Models for Humanities and Social Sciences. I'm Francesca Albrezzi. I'm here with my colleague, Brian Horn. And we would bid you good morning from Hal as well. We'll go ahead and just start with some introductions and then go over our agenda for today. So I'm the digital research manager and specialist in the Office of Advanced Research Computing. I've taught for digital humanities and in world arts and cultures / dance here at UCLA, where I also did my PhD. I've been serving as the editor-in-chief and director of the virtual gallery for the International Journal of Digital Art History. My background is in extended reality technologies, as well as sort of a wider range of digital computational tools. I wear a lot of different hats, as does Brian, one of them being serving as a UC Women in Tech committee member. And I will pass it over to Ryan to introduce himself.
Hello, everyone. I'm also an OARC. I'm a digital research specialist and technically Francesca's minion, as we like to say. I've taught DH classes here and at other universities. Actually, before that, I was, of all things, a software engineer working on neural net software in the early 2000s for Lockheed Martin. So I then ran screaming to academia and got a PhD in ancient history. And through that, have combined them to be things like basically involved with GIS, network analysis, linked open data. I'm managing editor on Pleiades, and I work with Plagios and a lot of other linked open data initiatives online. And here at OARC, I'm actually doing a lot of efforts to use AI and GIS together on our Hoffman cluster.
So today we'll be doing basically an overview. We want to talk about the sort of applications and current state of AI on campus at the moment, and we'll go over some definitions and basic concepts. Ryan will be also introducing natural language processing and large language models, and then we'll sort of think through different applications, best practices, and do some demos so that you can actually see some of these things in action. I'll talk a little bit about large vision models and vision language models and demo a few of those for you as well so that you get a sense of what those technologies do. We'll close out with a discussion of open versus closed AI. And we actually, as we were putting this presentation together, realized we have so much material. So we'll do a follow-up workshop actually on ethics and AI. We thought we were going to have enough time in this workshop to cover that, but it's quite a big topic. So we wanted to give it space as we dug into that. So come back for that talk this summer. And with that, I'm going to turn it over to Ryan to talk a little bit about what AI is good at.
All right, thank you. And let me just share my screen as well. Okay, so here we are. So what is AI good at? Well, I mean, we've all heard these terms. We've all thought about what AI is. And this is just a very quick hit list of things that AI is actually very useful for. One is pattern recognition. Now, human beings were kind of hardwired to recognize patterns, but we don't always see the big picture or able to, like, say, read an entire corpus of texts or look at tens of thousands of data points. AI is really good at doing that kind of work and finding some kinds of patterns in them. So saying, hey, there's a lot of these kinds of variables, or there's a lot of these kinds of words that are used in conjunction with each other, or these kinds of images look the same. That's really a strong point of AI. What it's not so good at is telling you what that actually means. AI is fantastic, again, at language processing, of taking massive corpuses of text, looking at, just how do we talk, how the structure of how we talk, how to take all that and actually understand as much as say computers understand anything, understand what languages actually are, how to go through that, and how to actually process that into, say, tokens or meaningful chunks of text. AI is also really good at image analysis. Um, how many of you have ever had a project or some kind of task where you've had to look at image after image after image, and they all start to kind of blur together and look kind of the same? You can throw, yeah, there's a couple of hands there. Yeah, like you've done that kind of thing. I actually have done like ancient coin work where I've sat down with stacks of, 2,000 note cards trying to find out little differences in the nose of Alexander the Great on each coin. AI is actually really good at doing that and doing that quickly because it's again looking for patterns within the images. AI is great at taking over the world. And what do I mean by that? I'm not meaning this in like a Terminator 2 kind of way. What it is really it's dominating the conversation a lot. I mean, all of you are here at a workshop because you've heard of AI to some extent, right? You turn on the news, you see AI all over the place. AI is one of the big business buzzwords. It's certainly replaced things like, say, big data or that kind of thing. So AI itself, as a concept and as a technology, is really driving a lot of the conversations that we're having in research and tech at the university. For you on this call, how many of you are instructors and have seen or are terrified of what AI can do or showing up in your classroom? And maybe a quick show of hands, how many of you have used AI in a classroom setting or in a work setting? Yeah, a few hands, a few thumbs up. We're all kind of using it. It's here. It's kind of like if you're old enough to remember Wikipedia when it showed up and everyone's saying, "Oh, yeah, it's here. We're using it." And what we're trying to do now is figure out how to use it and how to use it effectively. It's not good at. There's quite a number of things. One is in-depth analysis. Again, it can tell you that there's patterns, find the patterns, tell you that these words go together, but it has no inherent ability to tell you what that means. That's up to you, the humanist, to say what is actually happening here. What is the meaningful thing of this AI? It's not really good at understanding things in context. So again, if you have text, you don't understand all the history behind it. You don't understand the social aspects of the text. You don't understand for images where are these coming from, where are these being produced? Why do you want to see these images? AI cannot really tell you that. It's really not good either at really nuanced interpretation. Um, if you use this, let's say, have any of you done, say, word parsing or text parsing? You may get, or say even sentiment analysis, where the AI says, hey, these phrases seem negative, where they're being sarcastic, or that maybe there's a double meaning for something. And AI really, they're not good at detecting that yet. And so fundamentally, AIs are not actually thinking like a human yet. So you may think of the term like artificial intelligence. Oh, it's thinking like people. We're not there. AIs do not think like us at all. They're still systems. They're still machines. We're going to get into that through this presentation. But just remember that AIs they do lack that kind of human understanding or that human aspect of things. And you'll probably see that as you generate things, look at it, play with AIs more, that they're good at thinking outside of the box. They're not good at thinking about maybe some of the crazy ideas or weird angles that we as humans can produce when we're looking at things like text or images or what have you. And so with that, I'll switch over to Francesca.
Oh, thank you. There we go. So I'll share my screen again. Um, so as Ryan was saying, increasingly artificial intelligence and machine learning are being used as methods to conduct humanities research, social science research, historical research, and even artistic research. In terms of wrangling big data, AI and machine learning approaches increase our capacity to examine data at that corpus level, right? That the lot of data, big data level. In addition, AI and machine learning excels at synthesizing information, moving from that large scale data back down to sets of topics or key points that can direct research at a sort of detailed level. However, one of the main questions when it comes to utilizing AI and machine learning for research is how it's going to impact the historical record. So tools that mimic human production create confusion around notions of authenticity, right? Who originated a document? Who created the document? What's contributing to a document? And how do we know what's real for the historical record? And also questions like how and by whom are those determinations made? So in examining the utility of AI and machine learning tools, it's also important to consider how the humanities can be useful to the implementation of AI and machine learning. And so we'll talk a little bit about that today, but really I hope that you'll come back to our next workshop where we'll dig into that more deeply. But in terms of sort of the importance of this work, we actually just had a DataX and EDRI symposium that happened last week on the on research in the age of AI, which was really fantastic. And it featured important work that is being done by faculty across the campus on the use of AI for conducting research. This is just an example of how quickly work in this area is expanding. So while we can't get into all of this research, and if you weren't able to attend, please take a look at these faculty members and take a look at their work. And certainly this is by no means all of the folks across campus that are doing this work, but many of them. And in addition, there's also guidance and support that's being developed and is available. Our administrative offices have an AI FAQs page that you can take a look at. Chris Mattman is our Chief Data and Artificial Intelligence Officer. If you didn't know that we had one, we do. IT Services has a page on ethical services of AI, so please check that out. That's a great starting point. And also OARC has been developing a number of resources and workshops in this area. So we have our YouTube channel. If you haven't had a chance to check that out, I encourage you to take a look at it. And I'm going to pass it back to Ryan to talk a little bit more about the current state of AI at OARC.
So a couple of things we're doing here at OARC is we're supporting developing AI tools and applications. And you'll see here one of the basically documentation pages of using Olama on Hoffman 2 cluster. What that means is that, again, I would like to see just a quick thumbs up if you've heard of Hoffman 2 before. Oh, I'm not seeing anybody. Well, that's fantastic. If you're not aware of it, Hoffman 2 is our supercomputer cluster, basically, here at UCLA. And guess what? It's free. You can use it. You have a free account. You have free use of it. You can sign up after this presentation, sign up today, and get rolling on it. And what this is a resource that allows you to use a lot of the AI things that we'll be discussing here. You can actually do, again, like things like large language models for Llama. I've worked on putting Esri GIS object detection on there. We have AI for doing code on Jupyter notebooks. We're rolling out more and more functionality of this. And again, it's all free for you to use. And so this is something that is a resource. It's out there. We support it. We give workshops on it. We can help people use it. The account, we'll put a link here after I'm done talking about that. And you'll see that we do, again, have some documentation. And one thing that we are doing, for those of you who've done GIS work, is we're actually getting Esri products to run on Hoffman. And so this was an example of running their AI object detection, so drawing little boxes around rooftops so that you could actually identify where things are on a map. And this is something that is traditionally done by hand, and the AI actually does it with a pretty high success rate. So this would probably take, hours of painstaking line by line work. You just put it through Hoffman, hit two buttons, walk away, and it's done. So really we're really trying to support this. This has been a big push for us at OARC. And so just be aware that for your research, that's one of the reasons we're here, is to support your research and support you if you wanted to go through and actually start working with a lot of the AI tools and capabilities that we're going to be talking about today. So, what is an AI? And this is actually an image that was generated by an AI when I asked that question. I find it very dystopian and truly terrifying with the smiling children around a smiling, happy robot. This is definitely AI propaganda. But we'll get into what is an AI. And maybe just for a quick way of doing that, in the chat, just put in what is an AI? What do you think of immediately if I say the term AI? Okay, so the artificial large language model, Skynet. Okay, we've got some Goovinator fans here. Tool, computer generated, probability model, really good PR team.
Tools that may simplify some tasks, I see. Generative AI,
Mm-hmm.
any program or device that appears to think or perform such IT wonders that we credit it as intelligent. Yes, very
Yeah,
super.
silicon-based neural nets. Okay. Yeah, that was kind of where we were in the early 2000s. So there's a lot of different ideas about what an AI is. So we're just going to go through some very, very basic concepts of what it is at the moment. Um, what's interesting too is that none of these responses were something that's going to take over the world or an actual terror yet, which is good. So AI's definition. We'll do one, and I actually put this to the AI. Define yourself. What is an AI? And it ripped it right out of Wikipedia. So take that as you will. But basically, we're thinking about computer systems that are doing tasks that normally involve some level of human intelligence, or I would say human intervention. And what we want to do is kind of automate things that involve reasoning or learning or decision making. That again, like if we're doing things like pattern recognition, what we want is a machine that does good enough pattern recognition at a speed that was far exceeding humans and being able to look at documents that we can't do. So it's really trying to enhance the tasks that we're already doing. And we can see another thing here from IBM. This is one that's actually made by a human. And again, you can see that one of the things they're doing here is talking about simulating human learning, requiring human intelligence, but that's not quite what we're doing, is it? We're trying to make machines that do reasoning, but not necessarily human reasoning or human levels of thought. And so we're going to talk a little bit about why that is. Some basic concepts, and again, this is just so everyone can be on the same page. A GPU, you'll hear that a lot when we talk about AIs, and that's the hardware behind this. And a GPU is really useful for parallel processing, which is doing multiple tasks at the same time. And this is fantastic for AI because you're doing multiple decision making. If you're doing neural nets, you have multiple nodes that have to make a decision about an input. Um, for those of you who have built your own computers, this is also the stuff you put in to make like Doom run on your machine. So then we hear things like NVIDIA. We've got stacks of them here. These are GPUs. These are very specific pieces of computer hardware. AIs are also based on algorithms. We highly recommend you read Algorithms of Oppression by Sophia Noble to get more into what algorithms do and some of the problems and issues behind those. But these are a set of rules or steps that we say the computer to perform a task. An algorithm is just essentially a bunch of functions strung together, say, if A, go to B, if A plus 2, go to C, then from there do something else, and so on and so forth. What's important to remember about algorithms and about all AI work in general is it's really humans behind some of this. We've developed and made the algorithms. We've programmed them. We've put in our own biases. We put in our own viewpoints. And so there's no such thing as a pure, you know, algorithm that has come from the ether. This has all been influenced by human decision making. And training, you'll hear this a lot for AIs. And that's where we take a data set, put it through our algorithms, and say, oh, here's the outputs. So then we start tweaking the algorithm a little bit, saying, oh, Instead of an A, you identified this as a D, so we need to change some parameters or change some values. Run it through again. Okay, we're getting closer, so on and so forth. That's training, and that is an extremely long, painstaking process. It can be a very GPU intensive process, and that's why we have things like Hoffman that'll actually help you do this instead of spending 3,000 years of computing power on your own laptop. And this gets into things like tuning, where we really get into well, through training, are really getting to our parameters and really fine tuning an AI to a specific task or a specific problem. And you can overtune it, actually. You can make an AI so effective that it does all of your training data and goes through your models, but you put in something new and it doesn't know what it's doing. And so these are basically, it's walking a fine line between effective training and allowing it to actually consume other data. And we have these terms and more. We'll have the links available for you. If you can click on this glossary, it'll take you to a page for AI for humanists. Now, AI systems we can think of in a couple of different classifications. One is artificial narrow intelligence. And the idea behind this is, whoops, I didn't want to click yet, is that it performs a very narrowed task with this assigned data set. And so this is things like Google Translate, Siri, Alexa, that basically the task for Google Translate is to translate language from one language to another. That's it, not to reason, not to do anything else. It's a very narrow kind of parameter. And we can, if we look at, say, artificial general intelligence, or AGI, this is expected to learn and reason without human intervention. And this is trying to get to the same cognitive level as humans. We're not there yet. We have things that are somewhat autonomous. We have things that can do some kinds of reasoning or learning without us intervening. We don't have anything that we know of that has yet hit the same cognitive level of humans. So we're still more intelligent than our machines at the moment. They may change, but that we're still not quite there. And if we go there, and if we have machines which are as intelligent as us, or then the next step is artificial superintelligence, and that's what we refer to as the singularity. That's when we've made machines and programs which far exceed our ability to think or to have cognition. There's a lot of speculation of what happens next. Again, this is the AI generated image of the singularity, so it almost seems like the AIs are gearing up for a Terminator scenario. Who knows? So again, we are nowhere even near this yet, but that's the levels. Artificial narrow intelligence, we're there. Artificial general intelligence, we're getting closer to, we're not there. Singularity, that is still very theoretical and in the future. And so what does this mean for us right now? Well, because we're at the stage where the computers aren't quite thinking at the level of humans, we've got to intervene. We've got to do some certain things here. So this is good old-fashioned AI against generative AI. And good old-fashioned AI is, there we are, basically used for, this is the stuff you're probably pretty used to or pretty used to hearing. This is a large corpus analysis, image feature processing. This is our voice and facial recognition. This is where you learn by what we were saying before, the training kind of idea. You get a data set together, put it through the algorithms, see what the outputs are, go back to your algorithms, adjust them, put the training data through, keep going, keep going, and keep going. That's what good old-fashioned AI work is. Now, generative AI has the capacity for learning, and I'm putting that in scare quotes because it's not quite learning the way again a human does, but it's a different kind of learning. And what it does is it starts looking at and understanding patterns again, and it starts generating responses tailored to those patterns in those specific situations. So this is the kind of thing we get to machine learning, which we'll talk about in a second. And generative AI is what we're looking at for large language models, ChatGPT, these kind of things. So they're taking patterns of our language and producing outputs which are basically just from the patterns. They're not inherently understanding language the way we do. They're understanding how words are put together in patterns or how images are put together in patterns. So the image that we shared earlier of the singularity, the generative AI is understanding that when we talk about the singularity, the Terminator comes up all the time. And so that's a pattern that it's generating an image for. Any questions so far? And again, feel free to raise a hand, throw up a red check if you don't understand, or drop a note if you want us to go over anything. All right, so machine learning, what is that? This is a subset of AI technologies, and we're going to get into that in deep learning as well. And basically, remember how I was saying about these models and how I have to tune them, look at them, tune them, look at them, tune them. That's how I spent most of my days in the early 2000s. It was tedious. We want to do this now in code, saying, here's the input, here's our desired outputs. You refine it yourself until you can actually get to the outputs that we're looking for. And this is kind of automating this process. And we can do this through supervised and unsupervised learning. And so what do we mean by learning? Supervised learning is, again, the training. We understand the output. We put in the training stuff. We adjust it. Now, because it is machine learning, it does some of the really fine detail work for us. We would just sit there and say, no, this is incorrect. No, this is incorrect. This is correct. This is incorrect. And the machine itself will then try to figure out what those patterns were for making incorrect and correct ones. So we are there, we're intervening to some extent, but we're not actually getting into the really fine weights and balances and things of the algorithm. Unsupervised learning is that we just put stuff in and we say, you do it. You find the patterns, you identify what these mean in terms of output, and you start refining it to get there. So we're trying to actually unleash the AIs basically without any pre-existing thing of this is correct, this is the output I'm looking for that input. The AIs themselves are going to do it. We allow it to make its own classifications. And this is, again, really useful for us, like if you have thousands upon thousands of works you don't want to read, put them in, have it do unsupervised learning, find out what these clusters, these patterns, and these common features are. And reinforcement learning just takes that, does it again, over and over and over again. And what's really cool about reinforcement learning is that you do that where you say, I want you to get here, and here's some allowable moves that you can do, and then it actually figures out the algorithms itself. So this is like, it almost gamifies what you're trying to do, and it finds different paths of logically working through what your task actually is. And so then exploring the possibilities, really. And so this gets into how does this actually work? How do we put this stuff into practice? Has anyone heard of a neural network before? Okay, a couple of you have heard of it. If you know precisely how it works, you can go to your happy place for a minute while we go through this. But the neural networks are actually really important, and they were one of the earlier precursors to where we are now in generative AI, and actually are fundamental to how generative AI works. It's basically, it's inspired by our brains. It doesn't replace our brains, it's just inspired by. And it tries to look at, recognize patterns and relationships in data. And it does this through neurons, weights, biases, activation functions, and layers. And so what do all these mean? Well, it's made up of layers of nodes. And these nodes are basically computational things. They hold a function, they have an input, you figure something out, and you have an output. And it's so you have data that comes in, it is looked at, and then it is pushed into a certain direction to either another node or a endpoint. And you have different layers of these. And you'll see what those look like in a minute. Each neuron, with the thing that it's actually doing, is the activation function. That's what it takes the data. That's what's actually being done. The activation function. That's how it chooses where to push it to the next neuron. And how you do that is you have weights and biases. So, hey, this input, we're going to say if it's a certain value, then okay, there's a percentage of the time you should go do this action, or there's a percentage of time you should do another action. We adjust those. We adjust how much a neuron is taking in that information, saying, all right, this much is valuable, this much is not. How much weight should I put on this as opposed to that? This is something we do all the time, right? Like, how much value do you put into, say, news coming from a vetted source as opposed to someone screaming at the side of the road? You know, different weights, different values, different kinds of processing in and out. And these are used for basically all the AI stuff we're doing now is based on AIs. It's based on neural networks, excuse me. It's image recognition, NLP, speech recognition. All this is based on these principles. So that's why we're going over it. And it works kind of like this. You'll see an input layer. So this is a data that you have. And that data goes then, gets pushed to these nodes. This is what we call the hidden layer. And then computational things are done on them, on the data. And then the output pushes it to these, what we call output layers. And each one of these has a probability. So if you have something in, say, data that comes in, it hits this node H8, it'll say it has a 90% chance of going here. It's got a 10% weight of this. That would be 100, right? Or maybe it's got 50, 40, 30, so on. And so that's how it works. You get things in, it gives probabilities, it has weights, it pushes it out to the output. So you can say, hey, H8 1 to 8 all have picked this output at no less than a 50% probability. That's probably what you want to go with. But these other ones are possible, but not likely. And as you add more and more layers, this is where you get to deep learning, where each one of these is a node computational layer. Each time it says, all right, here's my input data, do a probability on it, do my outputs, push it to the next layer of nodes with my weights, with my biases, my ideas. Next one, do the computation with the weights and the biases for the previous one, push it to the next layer. And so you can see as you start stacking these things together, you have more and more computational power, more and more things looking at a piece of data, and you'll start seeing go through these different probability paths depending on what's being outputted. And then again, until you finally get your outputs, and then you say, all right, most of the time it's this, that's what we're going with. Any questions on that?
I actually had a quick question. Does
Mm-hmm.
every hidden layer perform like the same task, or is it sort of tuned to what comes before it and what comes after it?
Yeah, it's tuned to what comes before it and after it. So the previous layer will take data, do a activation function on it, figures whatever your task is, push it to the next layer, which then does a new task on it, but it's informed by the previous one. So the whatever the previous layer has determined is now where you're going for the next nodes. Does that make sense?
Yeah, it does. Thank you.
Sure. Yeah. So just think of it as almost like handing off a problem from one thing to another to another. Everyone's doing their specific transformation on it, but they know what's come before and they're learning as they do it, basically. So just think of each one of these as like a different learning opportunity for the system to figure out, oh, okay, I got this. That means this. That means this. That means that.
And we have another question in the chat, Ryan, uh,
Okay.
saying, is the hidden layer what a computational node processes, which humans cannot process, at least as fast as the computer can do?
Yes, exactly. So these layers are all basically nodes, or you can think of them as cores on a GPU, processes on a GPU. These are all things that are firing off simultaneously, doing calculations that we as humans simply cannot keep up with. So yes, that's what these are. Um, and what's interesting about them too is you can see that this is a traditional neural net where it's from layer one to layer two to layer three. We're starting to work on ones where within the layers they're actually connecting as well and stacking the three-dimensional space as well. So we're really starting to try to make these thicker and denser and behaving again a little more like actual neurons. We're not quite there yet, but that's again where we're heading. So how does this actually work? And let's look at natural language processing. And so this uses machine learning, deep learning neural nets training to actually try to figure out language, figure out how we talk, right? Because fundamentally, language is communication, it's patterns. I'm talking in a certain way, you understand that. If I started talking like Yoda, you can kind of understand that, but it's not really the pattern that you're looking for. So, same thing with here. And natural language processing does involve, traditionally at least, manual engineering, where we look at a corpus, we look at, say, a sample of Shakespeare or a sample of somebody's writing, and we say, all right, this is kind of the styles I'm looking for. This is kind of the input. You process it and tell me what it is that I'm doing here. And this is stuff like bag of words, if you've ever done that, which is counting like how many words are used in conjunction with each other. Spam detection, we've trained that because, if you open an email saying that you've won a lot of money, you probably haven't. This is also sentiment analysis, if people have worked with that. These are all things that are done with natural language processing. And once you do that, once we start getting into really deep neural nets, and the deep learning, like I was showing you before, the multiple layers, that's you start getting to LLMs and chatbots. And that's something that Francesca will talk about in a couple of minutes. And so let's just do a really simplified flow of how, say, language processing would work. You take an input text, whatever that happens to be, maybe a sentence, a question, a document. And then what it does is it breaks that up into individual words. That's what we call tokenization. So it goes through, says, all right, here's your word, here's a word, here's a word. Those are your tokens. And you'll see tokens also used for things like mathematics, for images. Think of a token as your individual unit that's being processed on. And so those are words or parts. Then it goes into word embedding. And what is word embedding? It looks at basically taking these tokens and transferring them into numbers or something that's more understandable from a machine perspective. We're always transforming our data to ones and zeros fundamentally at the end of the day. And so that's what word embedding does. And then you put it through your model processing. And so using these now tokenized text converted to numbers, the machine is now looking at how do these numbers go together to find its patterns. So it's not reading a text the way we read it. It's not reading it in the same like kind of emotional connection to language we're using. It's converting it to numbers and finding out how these numbers work together. And then the output is basically just the response, the generation of text or what have you. And so here would be an example of topic modeling. Has anyone done topic modeling before at all? Or have heard of topic modeling? So again, topic modeling being an example, if you take a bunch of text, you're trying to find out what is this text talking about? What is the probability that this document has some kind of meaning? And so these topics are found by our algorithm. And so what's interesting is this is an example of taking a pile of text, throwing it in, and the machine is saying that we have these ideas, machine learning, algorithm, and model go together a lot. So we'll identify that as a topic and call that machine learning. We find another group of words that are used together a lot, language processing, text analysis. Well, we would assign that as, okay, we'll call that topic natural language processing. And so these are the words that are associated with these topics. Again, the machine doesn't tell us what this topic is. It just tells us this forms a topic. We have to interpret it. And it tells us what the probability of a word belonging to that topic is. So you'll see that how strongly related. So language, whenever you see that in the corpus, it's saying that about 35% of the, 0.35 is associated with natural language processing as a topic. So over here, it's pretty good if you see machine, that is probably going to be machine learning. And so what you'll do then is take all this training that you've done, identified topics, identified the words, and put them into, is it say, all right, now let's take a much larger corpus of text, throw it in there, perform the same operation. And you'll see, so let's say that you have, I don't know, you want to look at all of Twitter data. You're not going to look at that yourself. You perform topic modeling on a subset. identify what that is, and then throw in the entire set of data that you have. And so this would be a sample output. So we have document nodes on the left. These are individual documents. And so in an excerpt to give you context, like deep learning models are used, machine learning is a field. And these are the edges, the lines connecting. And you'll see the color for which one it is mostly associated with. So saying that we have document 2, it has these words, deep learning, processing, text, and language, which are associated with our topic, but not as strongly as these words, machine learning models and algorithm. So then you would say that document 2 is probably associated with machine learning. The document 1 is probably associated with natural language processing. And that same with document 3. And so that's how this kind of task is performed. And so you can see here each edge and each kind of bunch of words and what the probability of those words being in there and the probability of those words being on a certain topic. Any questions so far? And you can tell that this takes a lot of reasoning, a lot of processing. And that's why we use an AI for this, because you don't want to read, or you can't read as a human, millions upon millions of tweets. You need something to identify it and tell you where these actually would wind up. And that gets us then into large language models. All right. And these are basically AI applications, and they're looking at really big data. So again, like massive amounts of Twitter data, massive amounts of text, and they're used to understand it again as far as AIs do, and generate text that's similar to how we use it in our language. And these are based again on deep learning neural networks. And for these, scale matters. The more data you have, the better your large language model is going to be. And something we were discussing our ethics one is how do they actually obtain that data? And what does it mean to have your data become part of an LLM? And we get into ideas of ownership and ethics around that. And so, again, these normally have training models, again, very involved and painstaking. And this takes a lot of time, a lot of computational power that these are not self-creating models yet. Data must be annotated by humans. Humans have to look at LLMs. That's why we have all this computational power behind it. That's why we have all these different interfaces to it. And that is, again, something that we're working on here at OARC. And if we have to annotate it, we have to do some of the training of it. What kind of training is that? What kind of learning? It's a pop quiz. Whoever gets it right gets spared by the machines.
Unsupervised?
We are actually doing supervised learning because we're involved in this loop. So ChatGPT and things have actually had humans supervising a lot of its actual learning. And you'll have heard of this of like ChatGPT, BERT, and this kind of thing. And with that, I'll now hand it over to Francesca.
Great. So I'm going to share, that was wonderful, Ryan, and I think it gives us a really good groundwork for just an example that I'm going to show from of this in sort of in research. So in digital humanities, for example, natural language processing can be applied to text corpus to better understand literary structures and patterns. So for example, Book NLP is a Python library created by David Baman and is designed for natural language processing of large documents like books, addressing the limitations of existing language models with lengthy texts. It helps digital humanities researchers by offering features like character name clustering or cross-referencing resolutions, and even event tagging, which are useful for tasks such as triple extraction, which is basically the process of identifying and extracting subject, predicate, object relationships from text, which is obviously so important, particularly when we're trying to think about when we're trying to break down these texts, right, in order to understand connections, and also in constructing knowledge trees, so graphical representations where nodes represent concepts or entities, and edges represent relationships between, and representing relationships between them from corpora. So in this example, a team at the Center for Artificial Intelligence and Data Science at Julius Maximilians University in Würzburg used book NLP to build a character, I should say, build a character network and visualize a narrative structure based on characters and generate descriptive statistics of Tolkien's Legendarium. Hopefully there's a few Lord of the Rings fans out there. Analyzing character occurrences in Lord of the Rings reveals that Tolkien's his use of this interlacing narrative style, right? And the team noted that a sort of similarity to the non-linear narrative structures common in early medieval literature. So they took these two different kinds of corpus, right? They took Tolkien's work, and then they took a corpus of medieval literature and recognized similar patterns, right? And so a genre, this medieval literature genre was something that Tolkien was really familiar with, and so likely was influenced by. So fields like computational literary studies are able to use LLMs and natural language processing to conduct entity recognition, this co-reference resolutions, the sentiment analysis, even scene detection and genre classification as part of their work. So a huge part of making these tools for work for you is how you talk to them, how you write prompts. And it's often called prompt engineering or prompt craft. And it's a skill that makes a massive difference when you're working with NLPs. So think of it like this: if you give a vague question, you'll likely get a vague answer, right? But if you give a clear, detailed set of instructions, the LLM is going to give you something much more specific and useful. So it's about guiding that conversation. So how do we do that? Well, first, we want to set the stage, right? We don't just ask a question in isolation. Give the LLM context, details, the backstory, if you will. If you're asking for research ideas, tell it about your specific interests in the field and the data types that you're interested in working with. If you need a summary of a document, provide the document or key points, and sometimes giving it specific data or examples of what you want helps it to understand the task that you're asking it to do much better. So paint a picture for the AI. Also define the deliverable. So tell the LLM exactly what kind of output you want. Do you need a bullet point list, a formal email, a simple paragraph? Do you need 3 pages worth of information, right? Specify the format, and that will actually really help the LLM deliver what you're looking for. You can also define the style. Should it be, professional or casual, persuasive, perhaps? One effective way of doing this is to ask the LLM to adopt a persona. So for example, you can say, explain this concept as an art historian, or write this pitch as a social science expert. You can even specify the audience. So for example, explain quantum physics to a 10-year-old. That would be me. Thanks very much. Love quantum physics, but need it broken down. Describe this technical process for a non-native English speaker. I really believe in AI for those who are trying to communicate in new languages or languages that are second or third languages. It's incredibly powerful as a way of helping people to really capture the sort of nuance of language and learn that by iterating. So these details can help shape the response significantly. Be direct with your instructions. Yes, please and thank you can be helpful, but what I mean here is use clear action verbs to start your prompt. Things like create, analyze, summarize, explain, compare, rewrite. This tells the LLM exactly what action that you need it to perform. It's often helpful to specify the desired length of the response. I sort of hinted at this earlier, but really to say, provide me a 3-sentence summary, or write about 200 words, or give me 5 takeaways, for example. This helps prevent either overly long or too brief answers in what you're trying to garner from the LLM. Sometimes also tasks are complex and you might not get the perfect answer on the first try. That's okay. If you're not getting what you need, break that task down. Ask it in a series of sort of smaller related prompts that build on each other to either iterate or experiment. If one prompt doesn't work well, tweak it, right? Try it again, maybe with slightly different wording. Maybe add more detail. Try a different approach. Getting a good result is often a process of refinement. And you want to think of it maybe more as a dialogue than a one-off command. I find that really helpful. And finally, this is crucial, always verify the output. LLMs can sometimes generate incorrect or nonsensical information. Again, as Ryan was describing, right? When it breaks things down into tokens and then converts it into numbers, it's not actually understanding this information. It's understanding patterns. And so it can understand a pattern, but get it wrong and weave together words that sound right, but have no meaning, or are actually not accurate in terms of the information that you're looking for. This is called hallucinations. And again, these answers, they might sound confident, but the information could be wrong or irrelevant. So never assume the output is factually accurate. Always check and vet the information, especially if you're using it for important tasks. We can often ask LLMs now, particularly these public ones like ChatGPT or Gemini, you can say, add citations, right? Double check those citations, because quite often it will try to deliver you something because you're asking for it, but it's not actually able to find the thing that you're looking for. And so you want to always be double checking and making sure these things really exist. And a great resource for prompts is, again, this AI for Humanists. Is it? There it is. AI for Humanists website. They have a section on prompts and how to craft prompts, and for different kinds of LLMs and different ways that you might adjust to get the kind of research responses that you're looking for. So do check that out as well. Okay, I think now we're going to do a series of demos. Ryan, do you want to take over for this and I'll support?
Sure. Demoing is always fun. All right, so we're going to do some use cases here for demos, showing you some, again, things that you might use it for, or we use it for brainstorming, outlining, looking at, trying to start generating things. We're going to look at a little bit of, as Francesca was just telling you, some prompt engineering as we're demoing these to get better responses than what we get initially. And so the first demo we're going to do, and one of the reasons we're doing this too, is we want to show you that even using the same tool with the same prompt, you're going to get different outputs. And part of this is actually due to personalization of, as you use tools like ChatGPT, it starts to recognize the words and the patterns that you're using and tries to tailor responses to you specifically. And also because of things like, again, neural nets, where it's Responses are probable. They're based on probabilities. They're not based on exact, this must happen. This may happen. And so you'll see a little bit of that. And so as a demo, let's outline a presentation on AI. Not that we've done that for this presentation, but just to say, you're, someone asked you to do a presentation. All right, let's just outline one of these. And so we're going to get into some prompt craft of this. So let's go ahead. I'll stop the share on this and reshare the actual. Here we go. You should not that you should not be seeing that. That's the wrong one. Here we go. This will be better. 30 windows with 5 different things at all times, right? All right, so let's go to our chat GPT and let's say that we want to do an assignment, which is first of all, outline an AI presentation. So I'm going to go ahead, put that in here. For those of you who've never used ChatGPT, you could just go to chatgpt.com and go ahead, play along. Why don't you put this in as we go and see what interesting things are generated for you? So I'm going to say outline an AI presentation.
And I'm going to type the exact same thing in on my ChatGPT window, and see how what are known as context windows, right? How those vary. So from my account to Ryan's account, these models have adapted to us and how we interact with them. So we're going to see if we get roughly the same answer or different answers because of our context window.
All right, so we'll see here we have understanding artificial intelligence today and tomorrow. All right, and Francesca, what do you have?
So I'm going to go ahead and share my screen now.
We should have tabs then, right?
Okay. I think that should work. So I've got the power and possibility of AI today and tomorrow. And so it seems here, we'll just look sort of at the outline itself and how it outlined for each one of us. You can see I have an introduction that's 2 to 3 minutes with some bullet points. What is AI? 3 to 5 minutes. Narrow AI versus general AI, right? Some of these concepts we've gone over. This actually has a brief history of AI. Ryan and I talked about that, but we chose not to put in a history of AI for this presentation, rather to jump to the part of the matter. How AI works, applications of AI today, benefits and opportunities, challenges and risks, and future trends, and then a conclusion and a Q&A. It also gave me some bonus tips. So Ryan, how does that compare to your outline?
Yeah, I've got a introduction, brief history, how AI works. I don't have any timings though. And so for you, it's actually done timings on your slides. For me, it's just thrown these little bullet points up. How AI works at a high level, types of AI, applications, opportunities, challenges, future. So takeaway, so it's similar, but you'll see there's subtle differences here. Now, what could be really interesting is if we say, well, let's try to make this a little bit different here. Do you see both of our screens or have the tabs that you can switch between them?
Oh, I think I've closed mine so that we can just go back and forth with the recording.
Okay, sure. All right. And so you'll see that these are pretty similar. And we have another one here that somebody has to, oh, actually, let's look at so this is one that somebody else has done. And you'll see that this one does not even, for Maya here, it has not even provided a title. And so you'd have to come up with your own title. The AI should do that for you. I mean, look at ours. And so let's go here and let's make this a little bit different. So we have an AI presentation, but let's say that we want to do something a little bit more with it. So let's do our next thing, which is let's create a college paper. And so let's go ahead and say, what's our prompt now? Create a college paper that discusses the pros and cons of AI use in the classroom. Add citations. So let's see what it generates for an actual paper, how long that paper is, and what we'll actually create. And go ahead and play along with this too. And so you'll see that we go through some pros here, personalized learning, some efficiency, data-driven insights, accessibility and inclusivity, I can speak today. Some cons, equity bias, we talked about that, privacy, depersonalization of education, teacher de-skilling. And you'll see that we have a little conclusion here, and then some references. And these, with the DOIs, well, some of these will actually exist. And you'll see that there are actually some citations. And what you will do is you'll check them. Like, let's say, should Roger replace teachers, AI in the future of education, Polity Press. Does that one actually exist? Okay, that one actually exists. And so you go through, you check these to see if those are actual things. We can make it shorter depending on your assignment length. That's a little frightening. Francesca, what did you generate with this?
Yeah, so I'll go ahead and share my screen. One other thing that I would add about checking references, if you do use ChatGPT or something like it, is sometimes they'll have these links. The links don't always go to the article that it is stating it goes to. So you also want to double check the links, right? Even if you check the titles and the authors and you're like, okay, that exists, the link itself may not actually go to the thing that it's talking about. So you always want to double check, right? In my case here, we can see, oh, go back up again. Similarly to Ryan's, instead of pros and cons, it's benefits and challenges. So you can already see how when we were talking at the very beginning of this talk around, historicity and how this affects the historical record and how AI may, in terms of research, when we think about the originality of research, if we're all pulling from similar places, we're all going to have similar outcomes. And this is what we tend to see with large language models, popular language models around popular topics, right? Is that this stuff tends to spit out the same kind of thing over and over again, tailored obviously to the person, but this is why crafting or prompt engineering, right? Prompt crafting is really important because that's where the originality will come in. So here, my outline looks very similar to Ryan's. If I were to then say, right, how might I adjust this prompt to get something a little more original? I might say, create a college paper that discusses, rather than pros and cons of AI use in the classroom, discusses the ideas of originality based on the work of Walter Benjamin, right? Might give it a specific scholar and say, so create a college paper that discusses in relationship, right, to AI use in the classroom. Add citations. Make the paper be 500 words. So again, I'm using these tools to start to add a level of detail that's going to hone the kind of outcome. Now, this gave me a title that just spit back what I wrote in. So I might have to actually ask it, give me a more creative title, give me a list of creative titles, right? But all of a sudden, this is starting to weave together different kinds of ideas and look very different from the previous outline that we had just seen, right? I could ask it to think about other kind of pedagogical theories and bring those in. And then again, it'll start layering that in, becoming more and more of a sort of less templated in terms of how it responds. All right. And Ryan, I think you wanted to talk a little bit about code generation, AI code generation in relationship to this.
Yes, and so, oh, and one thing too, that you could add before I even do that is, you could take a paper like this and just to show you, add a citation from
Yes.
about, so we'll say in the paper above about AI. And I don't want to. So this is pretty funny, because we really haven't, either of us, written that much about AI, and so um, I don't remember writing this with you, Francesca. Do you?
I don't believe we did. I don't
And
remember. I
so
don't recall that.
exactly, and so here it's saying that we have they've basically hallucinated a a work that is saying that we've created something from some university press. Now you can say it just says university press. That's kind of silly, but the point being that you can say cite a scholar's work, and it could just generate junk. And so be careful of that kind of thing, because again, neither of us have written that. Now there's a lot of, again, ideas and ethics behind this kind of generation of prose, of outlines and things. And we'll get into a lot of that for our next this talk. But one thing that AI is actually very good at is code generation. And so for those of you who have worked with code in your own work, you can do something like, let's just say in Jupyter, which, if you're familiar with, is an environment for Python coding. We'll say, um, create a script that takes a CSV file, um, makes a table in pandas, and creates a bar chart of values from the, we'll just call it from the measurement column. And so you'll see that if you want to do this kind of thing, this is, for those of you who understand Python, this is actually not bad. You're importing pandas, you're importing your libraries. It's reading your file. It's displaying the first few rows of the table. This is all very common. And it's making a little bar chart for you. And this, in this case, is pretty basic. But let's say that you have another larger task, like if you want to say look at a site's API or something. If you anyone here familiar with APIs and websites, like pulling data in from another source. So let's just say, here's one that I work on a lot, Pleiades, which is a gazetteer. And so just to give you an example what that is, if we're out, it's a record of ancient places and place types. And so what I could do here is say, let's go back to our code generation. I could say, you know, make a Python script, a record from those places, and This parses the JSON. It into a table. And you'll see that it actually finds out where the API is, which is pretty cool. And this is Rome. And it tells me, all right, we're going to do this request function. We're going to figure out the place ID. We're to get all of this data that's read from the API, return it, and make a table out of it. And so this is actually really useful for this kind of utility level code of saying, I want to extract data, or I want to pull things from a data source. I want you to put it into some kind of format, and then I, as a person, I'm going to take a look at that and actually reason with it. So what you can get into problems where it doesn't quite understand some of the things that's coming in, but in order to get you started, if you know any kind of code, this is actually really a useful tool. And you'll see that like here it is, it just read Rome, got its output, put in the URL. Now there's dozens of other things that I could have it bring down, but you'll see that it's already read a lot of this really important data right there. I could actually make a map off of this. So that's an example of code. One other thing that you can run, and I'll give you an example of this, is teachable machine. And we will put that in our chat as well. So you can check this out. This is a free thing. And what this does is allows you to put in a training set of data, whether these can be images, these can be movies, these can be sound files, and you classify them. And then you put in another set of data that you have not classified, and it attempts to classify it based on your training data. So what's fun? What's fun about this? We did this here at OARC, and I did it because I have a very serious issue with a lot of OARC events, which is I want to get a cookie, and I want to determine what kind of cookie it is. Right? We've all been in this. You walk in, you're trying to grab a cookie, and so the scenario is that you want to grab a cookie before I say you see me coming. There's two cookies. You want to grab one, right? Or scenario two, I'm at an event and I have time to grab one cookie, and you say, well, why do we care? We'll have I want to get a chocolate chip cookie and not an oatmeal raisin cookie. Have we all been in this situation where you have time to grab one cookie and you've got the wrong one? Or is it just me? Everyone's happy with oatmeal raisin?
Maya and I are
Okay.
team oatmeal raisin.
So we have a lot of oatmeal raisin fans. So maybe you want to get the oatmeal raisin one or you want to get the chocolate chip one. So the idea here was we have a classification. And so I used Teachable Machine with 8 pictures of chocolate chip cookies and 8 pictures of oatmeal raisin cookies. And then I had a testing data of 8 pictures of chocolate chips and 8 pictures of oatmeal. I knew what they were, but I was going to feed them to the machine to see if it could determine it. And using Teachable Machine, I put them in these classes. One was chocolate chip, one was oatmeal raisin, hit the training, the machine it ran this algorithms and it looked at it, and results being it found 100% accuracy on identifying oatmeal raisin cookies. Every cookie it said that was oatmeal raisin was indeed oatmeal raisin, and its lowest confidence of that was 96% confident that this was an oatmeal raisin cookie. So fantastic. It got 6 out of 8 correct for chocolate chip, but no false positives. So it didn't say an oatmeal raisin was a chocolate chip, which is good. Um, the two that it didn't quite know had plates, and so this is actually something to tell you about training data. I went back and noticed that a lot of these things had plates on them, so you want to isolate that image as it was actually looking at a pattern for a cookie being on a plate. And so basically it prevented me from eating an oatmeal raisin cookie, which is the whole objective of the entire thing. And so this may be a silly example, but you can look at this for all kinds of things. Like if you're looking at training for different kinds of coins, or say vegetation from a map, images before and after disasters, what's happened in these areas, time sensitive changes in images. These are all things that you can put through things like the teachable machine and actually get outputs that are reasonable and useful. So with that, I think now it is back over to Francesca.
Sure, and we're going to talk a little bit more about large vision models, also known as large image models, which are AI systems that are designed to analyze visual data. So what Ryan was just talking about, how do I know which cookie is the chocolate chip cookie or the oatmeal raisin cookie? These are trained with large image or video data sets. LVMs are used in image classification, object detection, image segmentation, image generation, and scene interpretation. Another AI system that is applicable to visual resource research are vision language models, which combine NLP, right, natural language processing, with LVM to create textual descriptions for images and answer questions about visual data and create visual data based on text inputs. For example, Jonathan Telmy created an app called the Living Museum app, and it uses generative AI to allow users to have quote unquote conversations with the objects in the British Museum's online collection. So I'm going to just do a quick demo of that so that you all can see this. So you can read a little bit about it here on this page. And then he has some that are certain exhibits that you're able to sort of go into and start with that. So I'm going to actually just start with ancient Egypt here. But you can explore the entire collection if you'd like. And so when I am in this, I can click on a particular object in the collection, and I start to have a chat with it. Now, I am presented with the metadata, so I can see what the museum's sort of authority file on this particular object is. And you can see in this case, it's not very full, right? It doesn't have a lot of interpretation from a curator already as part of it. So what we sort of have to assume is that the AI is doing a lot of the work here. And in the Living Museum app, the model is not constrained to the British Museum's archival metadata or to a specific curator's comments, but draws on outside sources to respond to us. So I have some questions here that I could pick from, or I could write one in. If you have one, feel free to type in the chat. I'm just going to choose, what is your purpose in ancient Egypt? And you can see that it's talking about, as a mummified cat, I held a special place in ancient Egyptian culture, right? And it talks about sort of the role that cats played in Egyptian culture, how they were revered, the association with the goddess Bastet. And so I can ask all kinds of questions here. For me, as someone who comes out of art history and cultural studies, I think, if we're not aware of all the sources of information that are that the AI answers are being drawn from, how's the user expected to assess the validity of the information as well as weight contextual positioning of the information, right? Does the authorship of the information matter in this context? Or is just the sort of razzle dazzle whiz bang factor of being able to communicate with an object the point, right? Is it about excitement, or is it about sort of level of research, or maybe both, right? What issues arise when AI becomes the voice of a museum object, I think is what this particular project brings to light here. we can obviously, say, tell me more about the goddess Bastet and learn more about wider sort of pantheon of gods and goddesses out of Egyptian culture. And it does circle around the object, right? It does try to stay sort of nested within the context of this object. But it's certainly interesting to think about, okay, well, where is this information coming from? It's also interesting, if we can clearly see that it can look at the object and note detail. So how does a computer see? Deep machine learning for visual material often operates by identifying the most important features or most unique characteristics of the visual material that it's looking at, right, so to speak. If you wanted to do handwriting analysis, the AI network in this case, here, this example here, it's a Siamese convolutional network. Convolutional neural network would focus on identifying the most important features of in the handwriting, right? And then generating abstract features as a numerical representation of those elements that it deemed most significant. So remember how Ryan was talking about the tokenization? Well, it's going to notice the particular way someone does their E, right? And it's going to note that over and over again and assign that a specific weight and go, that's a really distinctive feature. That's unique to this particular handwriting, and I'm seeing it over and over again. And so I'm going to assign a specific weight to that. So by essentially measuring the similarity or difference of those repeating features, the network can calculate the magnitude of difference between handwriting samples. So that's how it's able to differentiate if something is the same handwriting or different handwriting. So through a process of converting images to a numerical network, the model assigns varying values to different features, effectively learning to distinguish between the individual writing styles. Akrish Adhikari recently presented here at UCLA on how determining whose penmanship is present in a particular document can help determine authorship, right? Or help us think more critically about authorship. In addition, there's a distinction between the act of sort of thinking, right? They're creating an idea, and the physical act of writing, right? So when we talk about authors, right, we sort of sometimes meld those things together, but they're actually can be two separate things, right? And we can actually underscore the significant labor of editors and transcriptionists whose contributions profoundly shape our understanding of authorship if we're looking at handwriting. Marginalia is an important part of literary history, and knowing who made what suggested edit, maybe, perhaps, right, can help us better to understand the influence of thought on a particular piece of writing. So let's test this out ourselves using the handwriting analysis, this handwriting analysis tool. As it states on the site, this is multiple and different handwriting styles can be analyzed concurrently and sorted according to their different similarity to a questioned or unknown style. So similar to what Ryan was just doing with his cookies, right? We can do this with handwriting using this tool. A similarity score can be calculated for each predefined style to create a relative comparison between them with respect to an unknown style. The handwriting styles, scribes, right, do not need to be known. Only discriminative labels must be used for each different style or hand, right? We just need to note there's style 1, there's style 2, there's style 3. We have to know that these are different ones, and we just have to label them as different. So you don't necessarily need to know the author in order to assess, is this more like, scribe 1 or scribe 4? So this is just one, I should say, of a suite of softwares that this particular university offers. And so you may want to check out some of the other ones depending on the type of analysis that you want to do, right? But I just want to show you how quickly and easily you can make use of this tool. So you can go to download, right? And it's going to take you to this page. And I will point out that I tried this on both my Mac and my PC. It only worked on my PC. So unfortunately, Mac users, you're going to have to find a PC in order to make use of this. But it's as easy as downloading this zip file. And then it's going to open in your browser. So the tool will automatically open. You'll open an executable file. So I'm just going to show you what that looks like here. Let me open a window. I'm going to stop sharing. I'm going to actually share my whole desktop for this demo so that you can see everything. There we go. So let me bring over this window. So you'll see when you download the tool, you'll see a Win dash x64 file. You're going to go into that and you're going to see this hat3p5 executable file. So if I click on that, what it's going to do is it's going to open this tool in my default browser. So I'm going to give it a minute to do that. So you'll get a little window here. We're going to let it do its thing. And should open, I believe. There we go. It's starting to open. So we're going to give it a minute. There we go. So now you see it's opened up this tool and it says start the analysis, right? So I can go ahead and start using this. Now, for our example, I'm just going to go back here to my slides for a second. I wanted to double check the results or see what the results I would get for George Washington's farewell address, who actually penned it. Because we know Alexander Hamilton and George Washington shared a close professional relationship for many years, with Hamilton serving as Washington's aide-de-camp during the Revolutionary War and later as his Secretary of Treasury. If you've ever seen the now famed musical Hamilton, right, in the song One Last Time, where they're penning this farewell address, Hamilton looks like he's the one doing most of the writing. So using some samples from their paper collections at the Library of Congress, let us see if AI can confirm if President Washington actually penned his farewell address. So here we'll share our slides. You can go to Alexander Hamilton's papers, right? And you have a whole bunch of samples that you can pick from. Same with George Washington's papers and the farewell address itself. I've also gone ahead and created just a little spreadsheet for us just to keep ourselves clear here. And I went and I picked some examples, right? So I decided, well, let's do a letter that was written by Hamilton when he was quite young, right? So we know that that's his handwriting. We also have one from just a general correspondence that he did for to Lafayette, I believe. And then we have Hamilton's actual notes for George Washington's farewell address, right? So some of his scribbles and precursors, right, or drafts. Then we have George Washington's diaries from when he was young. So again, looking at their young handwriting, an example of some invoices, letters that he did, as well as the farewell address itself. So how I'm going to do this is I'm going to go into the tool, right? And I'm going to say start the analysis. Now here, you want to start with, it gives you these great instructions to walk you through it. I'm just going to say on my own that I'm going to upload. You want to start with the unknowns here. So I'm going to go into my Washington files, and I'm going to pick, I believe this one is the farewell address, this one at the top, 24. Yep, just double check that here. Right, so we see that that's the same file. And I'm going to say open. And now I can label this however I want to. In this case, I'm going to call it the farewell address because I know that's what it is. I can say assign. Now I could do this again and again, right? I could assign more than one file. So if I wanted to do, scribe 3, all of these things are scribe 3, and then I have other things that I want to see if they're attributed to other writings, I could do it that way. In this case, I'm just going to do one file, and I'm going to say and add handwriting style. So now you see that here, right? And then I click on next, adding labeled images. So this is where I'm going to give my known files, right? The ones that I know who they belong to. So I'm going to go ahead and go to upload. And for the rest of these, we're still in my Washington folder. So I'm going to upload this and say this is Washington. Washington, I'm going to assign that, right? And then I'm going to upload another one because I do have another one. Missing his G there, Washington. Okay, so I've assigned that one as well. So now you can see I have 2 current files assigned to Washington, and I could do as many files as I wanted to. But I want to compare it to another handwriting style, right? I want to compare it to Hamilton's. So I'm going to add another handwriting style here. And you can see that Washington's example files are here. Now I'm going to create a new set. So this is for Hamilton. I'm going to go into my Hamilton folder. And I'm going to upload all of these and assign them to Hamilton. Right, and upload again. And one more for good measure. All right. So I'm adding that one. Now you can see I have 2 here. Then I can say analyze the uploaded handwriting style. So now I can get an assessment of, which one the farewell address actually could be assigned to, right? Is likely assigned to. And I will say you can adjust the parameters here. They give you, again, some good instructions down below. The defaults are normally good enough, but you can adjust for the different kinds of analysis that you might want to be doing. When you're ready, you can click Analyze. And it takes a minute here, but at least it gives me a progress bar, so I know it's working. It's a little bigger so everyone can see. All right, so now it says it's done, and I can look at the results. And sure enough, with relative similarity, it says it's 77% Washington to only 22% Hamilton. Now, you can download the results as a spreadsheet if you want to, a CSV file, or you can download the key points so you can actually see the sort of images and how it was tokenizing or reading these things, which is incredibly useful to, again, double check the work, see what's happening sort of in the AI side of things. So that's how we can use these large vision models to look at handwriting to do analysis. The future of AI and machine learning in digital humanities and social sciences will likely include a fair amount of fine tuning. Ryan mentioned this earlier. I want to echo it again with this particular article. It's a great example. In the context of AI and machine learning, fine tuning is the refinement of a pre-trained model so that it can perform better in particular contexts. And so, for example, utilizing hand pose estimation or HPE methods on a set of European early modern paintings to classify and analyze pictorial hand poses still requires, or required, at least in this example from 2023, intensive manual cleaning and annotation by an art historical expert or set of experts in order to do that, right? These hand gestures, as hands are being articulated by artists, right? That's something that a computer needs help to understand. So domain expertise will be required to hone AI models for humanities, digital humanities, historical, social science research for, I think, a few more years to come here. It's important to keep in mind. As we're wrapping up, I just want to mention a couple of things. One, the technical barrier to entry for the field of DH may be lowered, or I should say DH and AI may be lowered through the increased adoption of tools like Microsoft Copilot that can interactively assist with writing and editing code. So if you're looking to do digital humanities, if you're looking to do projects like this and you don't have a coding background, this AI, assisted coding can really make a big difference and lower that bar and create greater accessibility. Digital humanities in particular, right? Ryan and I both come out of digital humanities. We know that it has a long commitment to making digital tools and methods more accessible and for fostering collaboration and promoting the development of transferable technical skills. And so I think, this is where we hope that people will lean in. And in that same regard, humanists also weigh in on the way that these tools are operating and what is really truly ethical and best practice here. So again, we're going to do another upcoming workshop where we'll talk more about the ins and outs of that. But I do want to say the scope at which AI and machine learning will be applied and continue to grow. I think we're going to see it in a number of areas, but one particular notable area is the field of disabilities and computing. LLMs are being combined with AR glasses. That's what you're seeing here in this transcribed glass 2.0 video. Basically to produce automatic transcriptions for those who are deaf or hard of hearing. VLMs are supporting better automated alt text generation for the development of tools to provide more accurate and detailed visual descriptions for those who are blind or low vision. DH can play an important role in shaping the next stage of UX and UI in these areas of AI as it's being adopted and not only for research methods, but also adaptive technology and encouraging inclusive workflows and outputs. So finally, I want to finish today's talk with Ryan, really talking about the way that AI can be both open or closed. It's really a spectrum, right? There are important ways that AI systems are open and closed, and we should be aware of them. We might think of it as, again, a spectrum, as this article by Angela Luna demonstrates. The code for the model itself could be released open source, where others can customize or contribute to it. Or it could be a proprietary set of code, right, to a particular entity, meaning that the code is only available to those with access and is protected under copyright. That's closed, right? That code set is closed then. The models can be released for public use, and still be closed. So that's what we see with something like, ChatGPT, right? It's proprietary software, but it's open and free to use for the public at different levels. In these cases, users should not assume that any use of the model is private or protected in terms of their own intellectual property. Your data is being captured and processed on their proprietary servers. So instead, you may choose to download and run an open source LLM locally using something like Olama so that your data is not shared, right? The AI system itself may also be designed to operate under more limited conditions. Imagine you just want to ask questions about a single set of documents, and you only want answers that can be found directly in that data, right? You don't want it searching the internet like we saw in the Living Museum app, right? You want it to just be focused on the particular set of data that you give it. AI knowledge retrieval systems, often using techniques like retrieval augmented generation, or RAG, RAG, okay, probe a single knowledge base or data set that a user defines, which increases output accuracy and context relevancy, right? Rather than drawing on many different sources, for example, a data set that's akin to the whole internet, this approach limits the data scope so that the system can only respond based on the information that it's been provided in that data set. More secure systems are necessary when it comes to using AI or ML for sensitive or protected data. Think of medical data, right? Think of anything that has to do with human subjects, right? We want to protect those things very, very closely and carefully. And so our follow-up workshop will address those types of things and get into the weeds. And we hope that you will come back for that. That'll tackle the ethics of AI, ethical concerns, things around the issues around trust and authenticity. How do we look at something and not know that and be aware if it's a real thing or propaganda, right? Also thinking about bias and fairness, what these algorithms are trained on really affects their sort of internal biases. And so looking at the work of folks like Joy Borlomini will be really important in understanding how that plays out. Accuracy and academic integrity, obviously, and intellectual property and ownership, something that we really care about here in academia. So with that, I think we'll end it there. We're ending a little early. We have enough time for discussion and questions. I'm also going to thank you all for coming and place in the chat a link to give us some feedback. We do these workshops for our community, and we want to know what you want to know, right? So we want to make sure that these are tailored to you and your interests. So if you wouldn't mind sticking around for that short feedback sheet, that would be fantastic. And Brian, anything to add?
Yeah, just as Francesca just said, we're really trying to design these for information that you want to hear. So if there's things that you want to know about AIs, or if there's things you want to know about that kind of development, let us know and we'll actually put on a workshop for it. One thing to also reinforce what Francesca was just saying, think of AI as they're tools. They're tools that really do assist us. They're not cognitive beings yet. They don't have their own thoughts. They don't have their own processes. They're tools that we've designed as humans to enable us to do our work, or enable us to do things differently than we've done before. This is an interesting. I mean, there's a lot of press about it. There's a lot of interesting developments on it, but they're not replacing human cognition. And you'll see that this is part of the struggle that we're having now about pattern recognition, image generation, text generation, that may spit out things that sound all right, but if there's still no thought there's no there, it's just patterns. And so, as you encounter these, as you use these, just be aware of that approach that as a tool. And, especially for our knowledge work, we're not replacing instructors anytime soon with AIs. And you know, and as instructors, as we showed you with some of this prompt engineering, you can turn on its head and put your own assignments into AI, see what the general output is, and you can start to detect those. And so there's a lot of like push and pull on how these are being used and how they're being approached. But I would say don't be afraid of them. Don't think of it as some kind of, you know, terrifying technology. Can be really highly effective, really interesting tools if used correctly. And that's one of the things we'll be doing next time is really getting into what are these ethical applications, where can you actually apply these and feel like you're doing, and you know, use it to enhance your work, not try to take over some of your cognitive processes. So with that, we'll open up to any questions or thoughts, observations.
Question?
Ah, yes, because part of, as we're saying about how difficult and intense the processes of making weights and fine tuning models. The reason why they're proprietary. It's like these are the you've spent you know, hundreds upon hundreds of hours of refining a weight question. The question here is AI model weights are treated as very sensitive information. They are because people refine these models. And so of all the time they put in of making these micro adjustments to their algorithms, micro adjustments to the weights and the biases to get what they want, that's why they're protecting those. Because that is that kind of labor that's gone into really refining the model.
It's why when, for example, if you ask, Google Gemini versus Copilot versus
Mhm.
ChatGPT, to do the same tasks, you may get very different results. I mean, they'll spit you out something similar, but people really do find that they may like, or that a particular model does something a little bit better than another model. I've certainly found that Copilot tends to deal with data sheets and just data a
Mm.
lot better, coding a lot better than something like ChatGPT. And that might be because of the way that they've weighted their model and the way that their engineers have sort of tweaked it on the back end, right, to make sure that it deals with that kind of information really well.
Right. And as you were just saying for the code, I've noticed sometimes in ChatGPT, when you're dealing with code, you get into kind of an infinite loop of fix this. Well, it fixes that, but breaks. All right, well, fix it. All right, well, now you're back to the original code again. It's really this loop of just, you just fixed that or you just did that. Why are you rooting it again? Because ChatGPT is more focused on, say, natural language processing, trying to have a conversation than it is to actually create code. And so you can see that these are the kind of, again, weights and tensions that they're trying to do. Other question, what are some of the ways that humanities researchers are using the Hoffman cluster currently, and how would you like to see these tools used? Um, yeah, we would like to see them used more, for especially from humanities researchers. There's some people who are doing there's again some GIS work on there, which is very computationally expensive. Um, Again, not price expensive, but takes a lot of computers to do. We don't have so much AI use yet because I think it's still the word's getting out to campus that the resources are there. We would like to see you guys take the lead on this. Like if you're doing, oh, I have like large language models would be a very obvious one. If you're trying to do, say, sentiment or network analysis, especially on huge data sets like Twitter archives, um, other kinds of just massive terabytes of data, getting your head around it, getting that into some kind of computational environment. We're starting to get there. We're also there's some linguistics work that I know I've been assisting people with in terms of trying to both crunch linguistics and its location and doing spatial computation. How about you, Francesca?
Yeah, linguistics, I think, is in comms. We have, I'm thinking of one of our projects that has to do with large amounts of news data. Um, that is our one of our biggest users. Mariana, you asked about collaboration with UC Health projects. It's tricky, but it's something that we're working on. Obviously, because of HIPAA regulations, there's certain security things that need to be in place in order for that to happen. I know, I believe their cluster has been separate for a while because of that, though we have run certain jobs that have been anonymized in ways that we've worked closely with PIs on. So it just depends on the kind of analysis you're looking to do. And actually recently at the symposium that just happened, the EDRI and DataX symposium that just happened, there was a great use case example by a psychologist who used AI to identify phenotypes, and then actually, because they didn't want to give away, personal data, they had AI generate sort of a test set of data that was anonymized and fake, right? Not based on real, but mimicked the data sets that they had. And then we're able to run that, and that could be shared, right? Because it was anonymized, it was no longer had the sort of personal markers that would make it dangerous to be able to share, or to overly sensitive to be able to share. And they were able to use that training data in the same way that they use the original training set and get the same kind of results. So we can now use AI to create data, right? Fake data, but data that can then be used to train other models and be released publicly. So that's another way that we're seeing it used.
And I've also worked with UCLA Health people in terms of mapping and looking at, say, doing spatial networks of where people are generally at like distances to different hospitals or different kinds of resources, or geographically where certain health outcomes are occurring, and taking those and running probabilistic statistics on it, and again using the Hoffman cluster to crunch all of that. So we do work with health people. There's a lot of room for collaboration there.
I should say we do also connect researchers with cloud services. So if people need cloud compute or sort of cloud AI compute, we have those resources that we can make available or set you up with. Any other questions?
Or maybe just to build off of that, one thing that we do want to make clear is we are here to support your research. So that's what we do at OARC. You send us an email, we will set up consultations, we'll see what we can do to help you. That basically connect you with resources, give you some assistance. That's why we're here. Yeah, there's actually, there's mostly they start off with real data. In a lot of the cases, we'll get into the ethics one too. A lot of that real data is stolen or otherwise should not have been there in the first place. But then you're getting into some really interesting problems now where people are training AIs off of internet data, which has been generated by AIs. And so and there's been some very interesting papers. I believe it was at the sixth iteration of doing that, the AI starts to get a little wonky. By the ninth iteration, it is just pure output garbage. And so people are doing that, and this is creating actually a very interesting problem of what is actually out there on the internet, what can be consumed for LLMs. The guess was that by the end of this month, or I think it was, or by the end of May, that the majority of the information on the internet will be AI generated. And so if you're going to be scraping the AI for AI models, you're now going to be taking AI input, feeding it back into an AI. And that's going to get into, unless you're really careful what your training data is. So that's getting some really, really fascinatingly strange situations.
Any other questions? Well, thank you again. And if you haven't already, I'm going to put the form in the chat again to give us some more feedback. We really appreciate it. Thank you all so much.